All right, well, let's go over the answers to the pendulum lab. So yesterday, what you would have done is you would have watched the video and I gave you some data to work off of. And now you've already filled that out and should have already submitted it. So now let's see, what would have the answers have been? So the first question said, predict will mass, length of string, or both affect the period of the pendulum. That part, excuse me, I wanted you to make a prediction. What do you think is going to be the thing that's going to affect, change that amount of time, amount of periods that we get going back and forth, or how long it takes for it to swing back and forth? So on that one, I can't really grade that one. That's up to you as to what you think was going to happen. So I get the next one. Says, when the pendulum hangs straight down, not swinging, does it have potential energy? So when it's just hanging straight down, does it have potential energy? Now on that one, I'm really looking at the idea, does it have potential energy in regards to swinging? No, it doesn't. It doesn't have any potential energy in swinging, it's just hanging. Now, grant, you cut the string, it'll fall, so it has that potential energy, but that's not what we're talking about here. We're talking about the idea of the potential energy of the period idea. Next one says, when you hold the pendulum up to the left, so you're going to hold it up, right, ready to swing, does it have potential or kinetic energy? Well, you're holding it up in the air. When you let go, it's going to go and swing down, so it has potential energy at that point, all right? All right, so then it has potential energy. Now, when you filled out the table, I gave you a bunch of data, and then you were supposed to calculate the average. So the first one, for the small with 15 centimeter length, you should have found the average to be 86, all right, periods back and forth. For the large one at 15 centimeter length, it also would have been 86. That interesting. All right, so I'm gonna go to the small at 25 centimeters. That one, the average would have been 41. And the large one at 25 centimeters would be 42 periods back and forth. All right, so now we go down to the conclusions. It says, what type of energy does the pendulum have when it's hanging straight down? So again, when it's hanging straight down, none. Doesn't have potential energy, doesn't have kinetic energy in regards to the idea of swinging back and forth. Question number 2. What type of energy does the resting pendulum have if it's held at a right angle to the stem? If it's held up here, all right, it's got potential energy. It's waiting to go. All right, so that means it's got potential energy. All right, we go to for me, the second page. What force acted on the pendulum when it was released from its raised position? So you pull it back. When you let go of it, what's the force that is pulling on it? Well, that's gravity. Right? And gravity pulls it down at a very specific rate, which happens to be 9.8 meters per second is the rate of gravitational pull. Question number 4. What string length caused the pendulum to swing more times in 2 minutes? So which one made it swing more? Was it the long string or the short string? Well, you should have noticed it was the short string. The short string ended up with an average of 86. The long string had an average of 41 and 42. All right. So when we look at which sinker size, did mass make a difference? So when we were looking at the short string, right, what did we end up with? Exactly the same number of swings. We had a short string, we had 86 for both of them. For the long string, we had 42, 41. That's pretty much the same. That's only a difference of 1. That's pretty minor. So the mass does not make a difference, right? Really, all the mass does, it makes it swing for a longer period of time. The big mass would make it maybe swing for like 4 minutes until it would finally stop. The little mass might make it, when you got down to about the 2 minutes, there ain't a whole lot of swinging left. It's pretty much done. So, all right, so it's really the length of the string. That's what decides how fast it's going to swing back and forth. Short string, it swings really fast. Long string, it takes a lot longer to swing. Number 5, describe the best method for increasing the number of swings on a pendulum during a time period. Well, what we want to do is we want to make, if we want to increase the number of swings, all right, then we need to make it shorter, all right, so that it swings back and forth faster and we'll get more swings. So if I make it longer, it's going to swing back and forth, and it's going to take longer, and I'm going to get less swings back and forth. All right, then we go to the diagram. All right, and on this diagram, what we're looking at is we're looking at some labels here. All right, so we got this one would be labeled A because that's got high potential energy. This spot would be labeled or labeled B. All right, happens to have, it's increasing its kinetic energy. Then we get down to this one. This one has lots of kinetic energy. Then we start coming up the other side. Then all of a sudden my kinetic energy is decreasing. And then this spot up here, all of a sudden I have lots of potential energy, so it's ready to go and start swinging backwards again. All right? So that would be the way in which you would have labeled that. So those are the answers for that activity. So, all right, well, I hope you get the idea that shorter the string, the faster it swings back and forth. All right, so if I have an old-fashioned grandfather clock that has a little thing that swings back and forth, all right, if my clock is always off, then I may have to either shorten it or make it longer to make it so that it swings back and forth, because that swinging back and forth is what gives me basically a second, right? So if it's really short, it might swing faster than a second, my clock will be wrong. If it's too long, then it's going to swing back and forth, and it's going to take longer than a second, and that's going to make my clock wrong. So I need it just the right length so that when it swings back and forth, it is 1 second, 2 seconds, 3 seconds, so that I get the clock to work exactly right. Okay. So with that, we will talk to you later. Have a great day.